Today we're going to be continuing with section 4.3, day 3, so still working with our derivatives of inverse trig functions, but now that we know the rules, we're really just going to be working with some applications. So the first warm-up is just to check again, do we know what these derivatives are, and can we apply them when we have to use the chain rule? So a couple quick examples. For my first one, I'm finding my function is inverse sine of x. So the first thing I notice is that since I'm just taking the inverse sine of x, I do not need to worry about the chain rule here. So I just need my basic formula for the derivative of inverse sine. So my derivative then is going to be 1 over the square root of 1 minus, I'm taking inverse sine of x, and then I square that. And again, since I don't have chain rule, that would be my derivative. For number 2, on the other hand, since I'm taking the inverse tangent of 2x squared, now I do need to incorporate chain rule. So my derivative for tangent, it's going to be 1 over 1 plus, it's going to be this inside stuff, 2x squared, and I'm going to square that. Right, this 2x squared gets squared, and then I'm going to multiply by the derivative of 2x squared, which is going to give me 4x. So my derivative is going to be 4x all over 1 plus 2 squared is 4, and then x squared squared is going to give me x to the 4th. And now I have to be careful here. There's nothing I can cancel because this term in my denominator does not have an x or a 4 in it, so then we're done at that point. So now, assuming we've memorized our derivatives, we know how to use those formulas, we're just going to do some quick application, one with particle motion, and then one finding equations of tangent lines. So for number 1, I have a particle moving along the x-axis so that its position is defined by this function here. And clearly we can see we have an inverse tangent function, so we're going to need to differentiate that. So now, they want to know what is the velocity of the particle at this given point in time. So we know that velocity is the first derivative of position. And our position is this function here. So we're going to take x prime of t, and we're going to use our formula for inverse tangent. So I know that's going to be 1 over 1 plus my square root of t, and I'm going to square that. And then I'm going to multiply by the derivative of the square root of t. So times 1/2 t to the negative 1/2. And so if I simplify that, I'm going to have 1 over, my 2 is going to go down. I'm going to move this t to the negative 1/2 down, so I have just a square root of t. And then I'm going to simplify what's in my denominator and make that just 1 plus t. So that is my derivative. That gives me my velocity function at any time t. And now the question is asking me to find the velocity when t equals 16. So we're just going to substitute that for t. So now v of 16 is going to be 1 over 2 times the square root of 16 times 1 plus 16. So I know the square root of 16 is 4, times 2 is 8, and I'm multiplying that by 1 plus 16 is 17. And so my answer is going to be 1 over 136. And the problem doesn't give me units, so I'm just going to leave it as is. So again, particle motion clearly is nothing new. The only thing that was new here was incorporating that derivative of the inverse tangent. All right, problem number 2 now. is asking us to find an equation for the line tangent to this graph at x equals -1. So I know that if I'm finding an equation of a line, I need a point and I need a slope. And we know that slope is the slope of the tangent, which means I need to find the derivative. So, first of all, First of all, to find that point, I know the x-coordinate of my point is -1. So now, to get my y value, I need to essentially solve this equation. Inverse cotangent of -1. And so what this question is really asking is where is the cotangent function equal to -1? At what value is my cotangent equal to -1? And using what we know about the unit circle, we know that cotangent of -pi/4 is equal to -1. So that's my y value. Again, we were trying to find out where is the cotangent equal to -1. I know cotangent of -pi/4 is -1, so that's my y value. So we've got our point. Now we need to find the slope of the tangent. And so we're going to differentiate our inverse cotangent of x. So I know that's the same as my inverse tangent. I just make it negative. Since this is just cotangent of x, I have no chain rule to worry about, so I'm just 1 over 1 plus x squared. So now I need to evaluate that when x equals -1. So I have -1 over 1 plus a -1 squared. -1 squared is just going to give us a +1, so my slope is going to be -1/2. So now I have a point and a slope, so I can write my equation, which will be y plus pi/4 is equal to my slope 1/2 times x plus 1. So those are, again, just some applications of where you might see these inverse trig functions come up. Tomorrow we'll do more practice.